Okay, so I'm holding my laptop different, hoping that this will be easier. Okay, so we're going to do even and odd functions. There are 3 different types for our even and odd functions. It's actually even, odd, and neither. So if a function is even, the way we figure this out is we're going to do our test, which means to plug in negative x into our function. If we plug in negative x and we end up with the original equation, we get the original equation. So we have the original f of x. Then that would be an even function, and an even function has symmetry along the y-axis, which means you could fold your paper on the y-axis and it would match. So our symmetry here is along the y-axis. Okay, so say we did our test and a function ended up being odd. The reason why this function would end up being odd is because when we plug in negative x into our function, we end up getting our f of x that we started with, but now all of the signs are opposite. So we could say all opposite signs, and you would actually write that as f of negative x. So our even function, we ended up back to the original function, nothing changed. With our odd function, what we ended up getting whenever we plugged in negative x is all of our signs changed. And so this type of function, the symmetry that we have is with respect to the origin, which means you would fold your paper on the x-axis and then the y-axis. So we're going to write origin. And then the last type is neither. So if we have a function and we do this test and some of the signs change, then that function is said to be neither even or odd. So some signs change. And so this one has no symmetry. None. Okay, so now let's actually do an example. If we have our f of x, our function is x squared. That is a parabola. That is a very poorly drawn parabola. A little bit better. Say we have a parabola. So it wants to know, is this an even, an odd, or a neither? So what we need to do is our test. And our test tells us to do f of negative x. So what this is saying is wherever you see an x, plug in negative x. And then if you remember the hint from last video, if you have a negative x raised to an even power, you get a positive x. And if you have a negative x raised to an odd power, you get a negative x. So if I'm looking at this, I notice that my power is 2. That's an even power, which means I'm going to get a positive x. So what happens here is my x becomes positive. Keep your exponent. And so if you notice, I did the test and plugged in negative x, and I got the same thing, same exact function that I started with. No signs changed. So this would say that it is equal to my f of x, which means that this is a even function. And this has symmetry along the y-axis. And if you notice, pretend this was on a piece of paper. If you actually folded it right there, the right-hand side to the left-hand side, they will lay on top of each other, and that is the symmetry. Okay, now let's say we have f of x is x cubed. So this is our cubic function. And what we need to do is our test. So if we do our test, what we're doing is we're plugging in a negative x into our function. Wherever I see an x, I plug in a negative x. This is an odd power, which means I have a negative x. Keep your variable. What I notice here is that this does not equal f of x. If I look at the function, I started with a positive x cubed, and now I have a negative x cubed. So that means that all the signs that could change did change. And so we would have an odd function. An odd function is symmetric about the origin. And so if you folded your paper along the y-axis, so you folded it down, and then you folded it along, why'd I say y? Let me repeat that. If you folded it along the x-axis, folding it down, and then you folded it on the y-axis, they would lay on top of each other, and that's what makes them symmetric about the origin. This, oh, you know what? Let me see. Let me do something real quick. See if this helps as far as visual is concerned. Y, X. Say we folded it about the X this way. We would end up having something similar to that. And then if we folded it about the Y, it would end up laying on top of itself. Okay, so now let's do this example. Say we have a function whose graph looks similar to this. So it looks almost like example 1. It is a parabola, but it's not at the origin right there. It's actually been shifted vertically and horizontally. And so if you just are shown a graph and you need to figure out if it is symmetric with respect to both or one of the axes, you need to be able to just look at it and tell that if you folded it along here, would it be symmetric? No. And then if you folded it along the X and then the Y, it wouldn't be an odd function. So we know if it's not odd and it's not even, then that makes it neither. And this is because it's not symmetrical. Not symmetrical with respect to x or y-axis. Okay, so now let's do this example. Up. Also, just one where you're shown the graph of a function. Oh, I didn't have that button pushed, sorry. Here we're just shown this right here. And it wants to know if this function is even, odd, or neither. And so I know that if it's even, it is symmetrical about the y-axis. And I do believe that if this right side of the graph is reflected, or if you were to fold your paper about the y-axis, I do agree that it would fall right on top of here, which means that it is symmetrical about the y-axis, which means it is an even function. Okay, and then let's do this one right here. Say we have a function that looks like this, and we need to know if it's neither, odd, or even. Well, if I fold it about the y-axis, that's actually going to bring this over here. So no, it's not even, because that didn't work out. But if I fold it along the x, so now I'm looking at something similar to this. And then if I fold it along the y, this is actually going to lay on itself, which means that this would be an odd function because it has symmetry with respect to the x and the y-axis, or it has symmetry with respect to the origin. Okay. Now let's do an actual example with equations, trying to see whether or not it is an odd or an even function. Okay, so say we have f of x is equal to x cubed, and then we have a negative 6x. The only way you're going to figure out whether a function is even, odd, or neither is to do our test, which is to plug in negative x. And so if we do the test, which is f of, my pen doesn't want to write, f of negative x, wherever I see an x, I plug in a negative x. So now we just need to evaluate. I know that because my negative x is being raised to an odd power, that will result in a negative x. And then if you look at 6 times x, that's 6x. Those signs are the same, so it's positive. And so looking at my signs, I would notice that Okay, so I do have now a negative, I'm so sorry, that's a cubed. Keep your exponent. I do notice that my x cubed was positive, now it's negative, and my 6x was negative and now it's positive. So this means that I got the same function, but all of my signs changed. Therefore, this would be an odd function. And that's because all signs changed. Okay, so let's do another example. Say they give us h of x, and the function we're given is x squared plus 2x plus 1. So I know the only way I can determine whether or not this is an odd, even, or neither of those is to plug in a negative x. Wherever I see an x, I'm going to plug in a negative x. So 2 times a negative x, here we have plus 1. I know that because my negative x is being raised to an even power, I'm going to get a positive x. If you do 2 times x, you get 2x. Signs are different, so it's negative, and then I have my plus 1. So I did it again. It's weird. Keep your exponent. Hopefully y'all are noticing the fact that I keep dropping it. I'm like working ahead in my head. Okay, so let's pay attention to our signs. I know that I started with a positive x squared, and I still have a positive x squared. I had a positive 1 and a positive 1. But if I look right here, I had a positive 2x, and now I have a negative 2x, right? So that means that some of the signs are opposite, some of the signs changed, and if some of the signs changed, not all or neither, or none, then the actual function itself is neither even nor odd. And this is because some signs changed. It's actually easier to write in cursive than it is in print. Okay, so let's do one more. Say we have g of x equals x to the 4th minus 2x squared. Odd, even, neither. Well, I can definitely figure that out by doing my test, which is plugging in a negative x wherever I see an x. I know that my negative x is being raised to an even power, which means I have a positive x. You do 2 times x, you get 2. Don't forget your exponent. You get 2x. Those signs are the same, so it's positive. And don't forget your exponent. Okay, so if I look here, oh, this is a very common mistake. I actually just made it. I got distracted with my exponents again. I'm going to redo this. So erase whatever you have on your paper. Let me say it differently. Whenever we look at our sign on our variable and we're paying attention to our exponent to see if it stays, if it changes to positive or stays negative, we're only using whatever that exponent is to evaluate the sign of our variable. We're not doing anything with it, so it stays. Make sure it stays, okay? And then you would look in the problem and evaluate any other signage that's going on there. So start over. negative x to the fourth. I know that my exponent is even, and so that means that, I'm trying to erase the yellow, so that means that my variable will be even. Keep your exponent. And then right here, this is what I'm looking at. And I know that my exponent is even, so that means that my variable will be even. Keep your exponent. And then right here is where I would look and see that it's being multiplied by -2. So this is the same thing. It's still being multiplied by -2. So that would be your final answer, which actually matches that original completely, which means that this would be an even function. And it's because when I did the test of f of -x, I got back to my original function. Okay, so that's it for this video. Thanks, y'all.